Hi everybody. So today's video is going to be about a very important concept in machine learning called principal component analysis. So principal component analysis takes a data set and then it breaks it up into separate components to figure out which variables explain most of the variance in the data set. So that's how dimensions are reduced in large data sets because there can be correlated variables that are just useless to have in the model and whatnot. So let's get right to it. So I'm going to come over here and do import numpy as np, import pandas as pd, and from sklearn.decomposition import PCA. Okay, so the PCA function over here is going to do everything. Like it can split up the components and whatnot. But I'm going to show you guys first the manual process to get the principal components. So I'm going to come over here and define data equals pd.read CSV of diabetes.csv. And then I'm going to print the first 5 values. So I'm going to do print data.head. So let me come over here and make this terminal bigger. So I'll do Python 3xpca.py. Okay, so this is our data set. So the variables in here are pregnancies, glucose, blood pressure, skin thickness, insulin, body mass index, diabetes pedigree function, age, and outcome. So outcome is just a classification. We're going to be using that. So it pretty much decides yes, you have diabetes as a 1 or no, you have diabetes, no, don't have diabetes as a 0. But we're not going to be using this in this video. It's going to be for a later video. So I will come up here and then just delete data of outcome. Okay, so now let me go ahead and print it again. Okay, good. So we've got all the other variables. So there are 3, 6, 8 variables in this, and I'm going to reduce this down to 2 principal components. So let me go ahead and get rid of that. So I'm going to do x equals data, and then I'm going to do dx equals x minus the mean of x, axis equals 0. So this will remove the noise by subtracting the mean, and let's go ahead and print it out. So I'll print dx. So let me clear that. Okay, so everything has been normalized in a sense. So now the next step is I'll start off by step 1, calculate covariance matrix. So this is going to be, I'll call it E for sigma equals numpy dot covariance of dx and rho var equals false. So let me go ahead and print the shape just to make sure the covariance matrix works. So I'll clear this, run it. Okay, good. So it's an 8 by 8. That's good. So then step 2, calculate eigenvalues and eigenvectors of covariance matrix. So this will be eigval, comma eigvec equals numpy dot linear algebra dot eigenh. So let's go ahead and print eigval dot toList. So now run it. Okay, so these are the eigenvalues of that covariance matrix. Now let me print eigenvectors dot toList. So run that. Okay, so these are all the eigenvectors of the covariance matrix. So now it's going to be step 3, sort eigenvalues and pull eigenvector index. So then this will be S index equals numpy.argsort. So argsort returns the index of the variables sorted. It sorts the variables but returns the index of where they are. So this will end up being eigenvalues. So then step 4 is going to be extract index. So I'll call this xvec equals eigenvector, freeze the row. and then go up to, or rather do S index, and then step 5, declare principal components. So that's going to be principal components equals 2. So let me go down now. So this is going to be step 6. Pull PCA index. So this will be, I'll call this X pull equals XVec to principal components. Yeah, so then now that we have that, step 7, compute principal components. So then this will end up being PCA, or I'll call this NPCA equals, oh wait, I think I missed a step. Let's see. I'll try dx multiplied by x pull. So now let me print NPCA. So I'll clear this, run it. Okay, so I have my 2 principal components. Oh, wait a minute. This was supposed to be reversed. Okay, so let me clear that. Print the principal components. Okay, good. Now this looks like a much more correct answer. So now that I have that, I'm going to come here and do step 8. Confirm with PCA library from ScikitLearn. So this will be SPCA equals PCA, and then N components equals principal components. And then this is going to be, I'll call that client, and I'll do SPCA equals client.fit transform of dx, and then I will print SPCA. So now let me go ahead and clear this first, then run it. Okay, so I got the same exact values for both principal component tests. So I guess I'll just leave it at that. I thank you all for watching this video. I'm going to keep coming out with more and more good machine learning content, so stay tuned. Peace out.